Can you solve this integral? In this problem, we're asked to integrate this proper rational function. Remember, it's proper because the degree of the denominator is larger than the degree of the numerator. To integrate this, we'll want to use our integration technique, partial fraction decomposition. So we'll begin by factoring our denominator. That gives us x plus 2 times x plus 5. We then go ahead and split up our fractions, where x plus 2 gets a coefficient of a, and x plus 5 gets a coefficient of b. We then go ahead and set this expression and this expression equal to each other, getting a common denominator here, and then canceling out the denominators. That would give us this working equation here. We'll then go ahead and use the Heaviside cover method, where we'll strategically choose an x value here, x to be -5, to cancel out this term, and then x to be -2, where we'll cancel out this term. Let's start with the x equals -5. Plugging that in, we get -3b equals 9, or b equals -3. Now moving on to x equals -2, we end up with 3a equals 12, and therefore a would equal 4. Now that we know a and b, we go ahead and plug them back into our equation. Then we just wrap up by performing the integral. Here, 4 over x plus 2 turns into 4 times the natural log absolute value x plus 2, and the -3 over x plus 5 becomes -3 times natural log absolute value x plus 5, and of course a plus c because we're working with an indefinite integral. In both of those integrals, we were using the integral of 1 over u du equals natural log absolute value of u plus c. Theoretically, these would require us to do a u substitution, but since the derivatives of each of these are just 1, we can shortcut and simply do that u substitution in our head.